In the last part, I told you the sad story of the death of 9-month-old Gloria Thomas from untreated eczema. Her homeopath father failed to comply with the advice of physicians. Was he justified in putting his faith in homeopathy? I think the answer is clearly no, and I'd like to share my reasons with you. First, I have to briefly explain what it means to me to be a rational skeptic. I base my decisions on a specific burden of evidence. I read the scientific literature for rigorous studies examining the effects of a treatment. The most rigorous kind of clinical study is the large population, double-blind, randomized control trial. Large population is self-explanatory, the larger the better, but over 1,000 patients from multiple locations is usually best. Small groups, say less than 100, tend to create a lot of sampling error. Randomized control trial means that two equal groups are created, one that gets the treatment and one that gets a substitute of some sort, the control group. The groups are entered into randomly, rather than based on some characteristic of the patient, which minimizes biasing by the researcher. Double-blind means that neither the patient nor the person giving the therapy have any idea which group they're in. Only after the study is completed are the groups unblinded so that data can be analyzed. The goal of a clinical study is to test if the treatment is better than the substitute that was used as a control. It's not always possible to conduct a clinical study with these characteristics. For practical, ethical, or economic reasons, we sometimes have to compromise. For example, I worked on a study of a cancer drug last year that couldn't ethically give a placebo substitute treatment to the control group. Instead, they got the current standard of care. We also couldn't randomize for ethical reasons. Patients had to be selected on their ability to respond to the existing standard of care. Only non-responders to the conventional therapy went into the experimental group. That limited the conclusions we could draw from the study, but it gave the patients the best chance of survival, and researchers try to never put lives at risk to gather data. When I examine a treatment, though, I will accept as the gold standard the randomized large population double-blind study. A big bonus for me is if the group publishing the study has no interest in the outcome. I'm going to assume most of you are familiar with homeopathy, the idea of creating dilutions of substances that contain extremely small amounts of an active agent, or even no active agent at all due to extreme dilutions. The idea has roots in the early 1800s, with a motivating idea of like cures like. Modern homeopaths have no physical evidence for the mechanism underlying homeopathy, which they speculate is based on water memory. Based on our understanding of physics, there is no physical evidence for any mechanism of memory in water, or even the capacity for any kind of memory beyond a few milliseconds. It is important here for me to differentiate between low potency and high potency dilutions. A low potency is a high level of the chemical substance being diluted. For example, 1x is a 1 to 10 dilution. 1C is a 1 to 100 dilution. 3C is a 10 to the minus 6 dilution. These will likely contain the chemical substance in a single dose. A high potency is a dilution that is statistically unlikely to contain the active agent. It's simply pure water. For example, the founder advocated 30C dilutions, which is 10 raised to the minus 60. It should be noted that 1/3 of a drop of some original substance diluted into all the water on Earth would produce a remedy with a concentration of about 13C. A single molecule of a substance diluted into every other particle of the universe, which is about 10 to the 80 molecules, is a 40C dilution. Some very high potency, and it pains me to call it that, are at 200C. The real test of homeopathy, then, is in the high potency solutions. We aren't interested in testing if low concentrations of arsenic have a biological effect. We know they do, but not from water memory. What I'll be showing you today is what is called in the scientific literature a meta-analysis, or systematic review. This is a paper that examines all the peer-reviewed publications and synthesizes that data into an overall picture. This is where my username concordance comes from. We're testing for agreement of the majority of studies that meet certain criteria of rigor. There are always limitations. For example, we can't include results that never get published, and this creates a substantial effect called publication bias. Sometimes researchers conduct a study but are unwilling or unable to publish the results because they are uninteresting or poorly constructed. This is often called the file drawer effect, as all those negative studies get shoved in a file drawer. There's also a related phenomenon called the Hark effect, hypothesizing after results are known. Here, the researcher alters the way data is presented after the results are gathered. For example, dropping out one of the groups from the study, or excluding certain data after it has been collected. These phenomenon, and others, are why drug trials must be announced in advance, have a detailed design document in advance that is complied with, and include a third-party auditor in all raw data collected during the study. Drug companies can't decide to bury a clinical study because the results are negative. They can't drop out adverse events from questionnaires, and they can't change study criteria in the middle of the study. Alternative medicine does not have to comply with these policies, making publication bias a major factor. The systematic review I want to share with you was done by a Dr. Ernst, a professor at the University of Exeter and a trained homeopath. He's also the author of over 700 published papers and the editor-in-chief of 2 medical journals, so his credentials are ideal for my purposes. This is actually a systematic review of the systematic reviews on homeopathy, published in the British Journal of Clinical Pharmacology in 2002. I'm going to read from the last part of the abstract where Dr. Ernst is talking about the reviewed studies. Collectively, they failed to provide strong evidence in favor of homeopathy. In particular, there was no condition which responds convincingly better to homeopathic treatments than to placebo or other control interventions. Similarly, there was no homeopathic remedy that was demonstrated to yield clinical effects that are convincingly different from placebo. It is concluded that the best clinical evidence for homeopathy available to date does not warrant positive recommendations for its use in clinical practice. Translation: it doesn't work better than placebo, and it certainly doesn't work better than conventional treatment for any known condition. And here's the final paragraph from the discussion section of the same article. In conclusion, the hypothesis that any given homeopathic remedy leads to clinical effects that are relevantly different from placebo or superior to other control interventions for any medical condition is not supported by evidence from systematic reviews. Until more compelling results are available, homeopathy cannot be viewed as an evidence-based form of therapy. This isn't a man with an axe to grind. This is a trained homeopath, a professor of alternative medicine. He systematically reviewed evidence and hasn't found any to support the magically based belief that water has a memory. So, was Thomas Sam justified when he put his faith in homeopathy to treat his baby girl's eczema, even when conventional physicians advised him otherwise? I think the answer is no. I hope that Gloria Thomas is the last victim of homeopathy, but I know she won't be. Thanks for watching.